Okay, so where complex numbers come into play when it comes to solving polynomials is that sometimes we're going to get what are called complex roots, which means we're not going to see these as x-intercepts of the graph, but they are going to be roots just of the complex form. So this part in this box kind of goes through that if you have a square root of a negative number, that you at least want to bring that negative out, turn it into an I, because the square root of negative 1 is I, so we're going to call that I square root r. The idea there is that we can then say that we have a root. It's just going to be imaginary. So I've got a couple of equations here we're going to get complex roots for. So the first one, x squared plus 9 equals 0. If I wanted to solve this equation, I would simply subtract the 9 over to the other side, and then I can take the square root. Now, I'm taking the square root of a negative number. Okay, so first of all, when I take the square root, I need to make sure I say plus or minus, right? Plus or minus the square root of negative 9. If the number itself, so ignore the negative, if the number itself is a perfect square, go ahead and do that. So the square root of 9 is 3, but because it was negative, I'm going to attach this I to that. So it's going to be positive and negative 3I. If that number itself right there is not a perfect square, then just bring the negative out, make it an I, and say I square root of whatever that number is. You still want to simplify a radical if you can, but it's okay if you still have a radical as part of your answer. Just make sure that at the very least you're taking that negative out and making it an I. Okay, so those are our complex roots here. The next one looks like something that you could factor and solve here, but unfortunately this does not factor. So I need to go to the quadratic formula, which would say x equals negative b, which would be 4, plus or minus the square root of b squared minus 4 times a times c, all over 2a. I'm going to simplify this down. Negative 4 plus or minus the square root of, on the inside, 4 squared is 16. 4 times 1 times 5 is 20. 16 minus 20 would be negative 4 over 2. So negative 4 plus or minus the square root of negative 4. So again, 4 is a perfect square. So that's going to be 2, but because it's negative, 2i, and then divided by 2. So my last step here would be to go ahead and divide each of those terms separately by 2. So if you're going to do that, you need to divide both the term out front and this term by 2. So that's going to give me negative 2 plus or minus I. Do know that that is two different solutions. So that's negative 2 plus I, which is a complex number, but it's also negative 2 minus I, again, a separate complex number. So there are two solutions there. Same thing over here. I've got 3i and negative 3i. So make sure that when you get a complex solution, you realize that you're actually getting two of them. Every single time that you have a complex solution, you will have both. You'll have the conjugates. You'll have the plus and the minus aspect of that. Because when you get a complex number as a solution, it came from doing the square root of a negative, and every time you do a square root, you're saying plus and minus that thing. So every single time, complex roots come in pairs.